On the night of March 15, 2024, a signal traced back to NASA's Lunar Reconnaissance Orbiter briefly flickered across monitoring displays at Goddard Space Flight Center. At first glance, it appeared to be nothing more than routine telemetry. But within hours, that assumption collapsed. What should have been ordinary data triggered a quiet yet urgent exchange of communications between NASA, the European Space Agency, and Japan's JAXA. The information revealed something no one was expecting. Not in distant star systems, not in faraway galaxies, but right beneath us, cosmically speaking, the moon. That pale companion humanity has observed for thousands of years was behaving in a way it wasn't supposed to. Before we continue, I need to make something absolutely clear. This is not a story about aliens. It isn't about hidden bases or interdimensional gateways. What I'm about to share is far more compelling precisely because it's real. Because the confirmed science of our moon, the verified measurements, the peer-reviewed studies, the unanswered questions keeping lunar scientists awake at night, is already strange enough without embellishment. And what researchers have now confirmed is forcing a re-evaluation of assumptions we've held for decades about our closest celestial neighbor. To understand why this matters, we need to go back to 1969, not to the historic landing itself, but to something that happened afterward, something most people have never heard about. When Apollo 12 intentionally crashed its lunar module ascent stage into the moon's surface, seismometers left behind by astronauts recorded an astonishing result. The moon rang like a bell. It vibrated for nearly an hour. Dr. Clive Neal, a professor of planetary geology at the University of Notre Dame, described the event in a 2006 NASA interview as deeply unexpected. Those reverberations suggested the moon's interior was far more complex than existing models predicted, possibly containing structures or voids we didn't yet understand. That observation, made more than 50 years ago, has never been fully explained. And now, with streams of data coming from instruments the Apollo scientists could never have imagined, we're encountering more anomalies, not fewer. The Lunar Reconnaissance Orbiter has been circling the moon since 2009, quietly compiling the most detailed map of another world ever produced. Its Diviner lunar radiometer measures surface temperatures with extraordinary precision, tracking how heat moves across the lunar terrain. Most of the data aligns with expectations. Sunlit regions soar past 120 degrees Celsius. Shadowed areas plunge to minus 170. But in 2023, researchers at Arizona State University published findings in Nature that changed the conversation entirely. They identified a thermal anomaly inside a pit located in Mare Tranquillitatis, one of more than 200 such pits imaged by ELBRO. The temperature readings indicated something remarkable. The pit maintained relatively stable conditions, hovering around 17 degrees Celsius, regardless of the extreme temperature swings occurring on the surface above. Room temperature. On the moon, Dr. Tyler Horvath, the study's lead author, noted that these pits could provide shelter from the moon's brutal thermal environment. They may connect to lava tubes below, cave-like structures carved by ancient volcanic activity. But what caused scientists to pause was the consistency. The thermal stability was almost too perfect. Natural caves on Earth still show temperature variation. These readings showed striking uniformity, as if the environment were being regulated. Now, to be clear, no one is claiming artificial control. The leading explanations involve the thermal mass of surrounding rock, the geometry of pit openings, and insulating properties of lunar regolith that we don't yet fully understand. Still, the finding raised a question that continues to echo through lunar science. What else beneath the moon's surface have we overlooked? That question leads directly to discussions scientists have been quietly having since late 2023, and which finally entered public awareness in early 2024. The Grail mission, active from 2011 to 2012, produced the most precise gravity map ever made of any celestial body in our solar system. By tracking tiny variations in gravitational pull as twin spacecraft orbited the moon, scientists identified mass concentrations, known as mascons, hidden beneath the surface. Most of these made sense. Ancient impacts left dense material buried underground, creating gravitational signatures that tug slightly harder on passing spacecraft. But a handful of anomalies resisted explanation. One region on the lunar far side, near the crater Korolev, displayed a gravitational pattern that didn't match known impact models. The density profile suggested either an unusual mineral composition or a subsurface structure that current theories of lunar formation struggle to explain. Dr. Maria Zuber, principal investigator of the Grail mission and MIT's vice president for research, acknowledged in a 2023 interview with the Planetary Science Journal that some gravitational anomalies remain unresolved. She emphasized that these unknowns don't point to anything unnatural, but they do underscore how incomplete our understanding of lunar geology still is. That's the honest reality of science. Not every mystery signals something extraordinary. Most, once solved, reveal processes we simply hadn't considered. But taken together, the thermal stability of lunar pits, the anomalous seismic ringing, the unexplained gravitational signatures, they depict a world far more dynamic than the inert rock we once assumed. Now we arrive at the event that ignited the current discussion. In February 2024, NASA's Scientific Visualization Studio released updated thermal data from ongoing LRO observations. Within that release, researchers noticed something unusual. A region on the moon's near side, visible from Earth but rarely examined in detail, showed temperature fluctuations that didn't align with solar illumination cycles. The area lies within Oceanus Procellarum, the ocean of storms, a vast basaltic plain dominating the moon's western hemisphere. Repeated thermal passes revealed temperatures rising and falling in patterns unrelated to day-night transitions. Something was generating heat intermittently or reflecting thermal radiation in unexpected ways. Dr. Benjamin Greenhagen of Johns Hopkins Applied Physics Laboratory, a co-investigator on the Diviner instrument, addressed this at the Lunar and Planetary Science Conference in March 2024. He explained that some variations likely result from compositional differences in the regolith, such as iron or titanium content affecting heat absorption and release. But he also acknowledged that a subset of observations remains difficult to reconcile with existing models. His words were cautious, but consequential. We're observing behaviors that must be understood better before humans establish a sustained presence. That is the real warning. Not monsters, not visitors. A warning about our confidence, about assuming we know the moon well enough to build permanent settlements there. NASA's Artemis program, which aims to return humans to the moon and eventually construct long-term habitats, depends on an understanding that these anomalies suggest we may not yet possess. Consider lunar dust. Apollo astronauts quickly learned that lunar regolith behaves unlike anything on Earth. It clung to everything, abraded seals and visors, and raised concerns about respiratory exposure. Harrison Schmitt, the only geologist to walk on the moon during Apollo 17, experienced allergic reactions he attributed to inhaling lunar dust. Studies published in GeoHealth in 2022 confirmed that simulated lunar regolith causes significant lung tissue damage in laboratory settings. The particles are sharp, electrostatically charged, and chemically reactive when introduced into human biology. Dr. Russell Kirschman of NASA Ames wrote that prolonged exposure poses serious health risks that current spacesuit designs may not adequately mitigate. Now add thermal uncertainty to that equation. If subsurface temperatures fluctuate unpredictably, if unmapped heat sources exist, habitat design becomes vastly more complicated. The pits once considered ideal shelters now raise troubling questions. Why are they so stable? What processes maintain those temperatures? And could those same processes change suddenly? This is where restraint matters. There's a temptation, especially online, to jump from uncertainty to conspiracy, from unexplained to extraterrestrial. But that leap cheapens the genuine wonder of discovery. The moon doesn't need alien artifacts to be extraordinary. What scientists are actually doing is far more compelling. Teams across the globe are cross-referencing thermal data with compositional maps, comparing radar returns from missions like India's Chandrayaan-2 with Grail's gravity measurements. Japan's Kagaya mission gathered far-side data that's only now being fully analyzed using modern computational tools. In January 2024, a paper in Icarus proposed that some thermal anomalies may originate from residual volcanic heat, remnants of activity far more recent than previously believed. Traditional models placed the end of lunar volcanism around 1 billion years ago. But growing evidence suggests certain regions may have remained active within the last 100 million years. If true, it implies the moon retains more internal heat than expected, possibly driven by radioactive elements like thorium and uranium mapped decades ago by Lunar Prospector. That opens the door to episodic heating, outgassing, or localized thermal events even today. This connects to reports of transient lunar phenomena, brief flashes and glows observed since the 1700s. NASA cataloged over 300 such reports in a 1968 technical document. Many scientists now believe these events, if real, stem from gas release from subsurface pockets. But the mechanism remains uncertain. LBRO imagery has also identified surface features that appear to have formed within the last million years, geologically recent. Some researchers attribute them to tectonic adjustments as the moon cools and contracts. Others point to more provocative possibilities. In 2019, China's Chang'e 4 lander detected a gel-like substance in a small far-side crater. While later identified as likely impact glass, the discovery highlighted how incomplete our understanding of lunar chemistry still is. Taken together, these findings don't point to a single mystery, but to an accumulating realization. The moon is more active, more complex, and less predictable than we assumed. As Artemis advances, as agencies plan bases and resource extraction, as private companies look toward mining and tourism, these unknowns become urgent. The warning gaining traction is simple: we may not be ready. Our lunar models, largely built from Apollo-era data, may not capture the full variability of surface and subsurface conditions. Dr. Clive Neal has repeatedly emphasized this point, particularly regarding seismic risk. Moonquakes have reached magnitude 5 and can last over 10 minutes due to the moon's fractured, water-poor interior. Where do you build if you don't know which regions quake? How do you design habitats if temperatures below the surface may shift unexpectedly? These aren't abstract questions. They're engineering challenges tied directly to scientific gaps we're still trying to close. There's a humbling parallel here with deep ocean science. We often say we know more about the moon than our own seafloor. Yet both realms continue to surprise us. The moon, once dismissed as static and understood, is revealing layers of complexity we're only beginning to grasp. The scientists studying this aren't chasing spectacle. They're analyzing data, testing hypotheses, revising models. It's slow, careful work, but that's how understanding grows. What comes next depends on missions already planned. NASA's Viper rover will explore the lunar South Pole, searching for water ice and characterizing local geology. Europe's Argonaut program aims to deploy payloads across the late 2020s and 2030s, including new seismometer networks. Private companies are opening new pathways for frequent surface access. Each mission offers a chance to test assumptions against reality. And so we return to where we began, to that signal, to those unexpected thermal readings, to the difference between what we know and what we merely assume. The moon was never boring. Our perception of it was limited. Now, instruments like Diviner and missions like Chang'e and Chandrayaan are revealing a world of subtle complexity. That complexity isn't frightening because of lurking danger. It's unsettling because it exposes how much confidence can outpace knowledge. As humanity prepares not just to visit the moon, but to stay, that realization matters. The real warning is a call for humility. Measure before building. Study before committing. Understand before risking lives. The moon still hangs silently in our sky, but the data tells another story, a world evolving, hiding secrets, and rewarding those willing to look carefully. The question isn't whether the moon will surprise us again. It's whether we're ready to listen. Because listening is what science demands when certainty runs out. Every measurement sent back from orbit, every subtle deviation in temperature or gravity, every anomaly that refuses to fit neatly into our models is not a threat. It's an invitation. An invitation to slow down, to question, to replace assumption with evidence. The moon is not defying us out of hostility or intent. It's simply being what it has always been, a complex natural body shaped by processes we are still learning to recognize. History shows us that the greatest failures in exploration didn't come from the unknown itself, but from the belief that the unknown had already been conquered. From oceans crossed with incomplete maps. From environments entered with confidence that exceeded preparation. The moon now stands at a similar threshold in our story, not as a destination we've mastered, but as a place reminding us that proximity does not equal understanding. As Artemis timelines advance and hardware moves from design tables to launch pads, the most important mission may not be the next landing, but the next question. Where are we wrong? What have we oversimplified? What data have we dismissed because it complicated the narrative of readiness? The moon isn't warning us to stay away. It's warning us to pay attention. And that may be its most valuable lesson yet. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.